Good morning. Today we'll be talking about lesson 5.2, solving polynomial equations algebraically. We'll be discussing different techniques of solving equations. We'll talk about sum and difference of cubes. That's a new topic that will be discussed. We'll talk about how to factor different polynomials using different techniques. We used to factor power 2 polynomials. Now we'll start to factor higher degree powers by combining cubes and squares as well. We'll discuss some real-world examples, and finally, we'll talk about quadratic form and writing equations in quadratic form in order to solve them. So you have previous information about quadratic functions. How can we factor them? Today, we'll study the factoring techniques for higher degree polynomials. Our new vocab will be prime polynomials and quadratic form. Let's discuss a little bit what we have done before. Depend on polynomial itself. For any number of polynomial, the first step to think how to factor is the GCF. Always we try to find the greatest common factor between any number of terms that enables us to simplify the polynomial to make it easier to factor. Now, if it was a binomial, we check whether it was difference of two squares. Difference of two squares means a square minus b square. The first supposed to be perfect square, the second supposed to be perfect square, and it's minus between them. In this case, I can factor the difference of two squares by factorizing a plus b times a minus b. And it's always difference of two squares. There is no sum of those squares. So difference means always supposed to be minus between them. If it's not a binomial, if it was a trinomial, then we'll try to find the general trinomial ax squared plus bx plus c. Usually we check whether it's perfect square trinomial, or we can just use guess and check to open two brackets and factorize it normally. If it was 4 terms, we usually, or sometimes 6 terms, it's usually by grouping. We group the first 2 terms together. We are trying to find the common between them. The second 2 terms together, we'll try to find the common between them. Then again, by GCF, we can factorize it. We'll go through these techniques again and again while we're solving with the new technique. We'll be talking today about sum and difference of cubes. Remember, we said there were only difference of two squares. Now we're talking about cubes. Cubes mean power 3, like 8 is a perfect cube because it's 2 by 2 by 2. If we say 27, that's a perfect cube because it's a product of 3 by 3 by 3. While let's say 16, that's not a perfect cube because you cannot find a number multiplied by itself 3 times to get 16. That's the mean of cube, a perfect cube. Now for cubes, we have sum of two cubes and we have difference of two cubes. Remember, now just you have to memorize the rules. The sum of two cubes, it will be divided or split into two brackets. The first one is just simply a and b, a plus b. Then the second will be a squared minus ab plus b squared. Look at the sign. The first bracket carries the same bracket. Plus, plus. If it's minus, it will be minus. Then the second one will be a squared minus ab. Don't get confused with the perfect square trinomial. It cannot 2ab. It cannot be 2. It's just you have to memorize it. It's ab. Then a cube minus b cube. It will carry the same sign, negative, negative. Then here will be plus, plus. Remember that always the last sign will keep positive. So just those two, you have to memorize them in order to help you to factorize later. So let's say, factor the polynomial x cubed minus 400. If the polynomial cannot be factored, write prime. If you take a look at this one, you can recognize that we have here x cubed. X cubed is a perfect cube because actually it's x times x times x. What about 400? What number multiplied by itself 3 times can give you 400? Or you can just think, what is the third root on your calculator of 400? It's equals to what? Since you cannot get a whole number, then 400 is not a third root. It's not, sorry, 400 is not a cube. 400 is not a cube. That's why we say that this polynomial is prime. So we write our polynomial is prime. The first term is a perfect cube, x cubed, but the second term is not, so it's prime polynomial. Prime polynomial means it cannot be factored more and more. There is no other factorization for this one. So it's totally prime. I cannot factorize, I cannot split it out into two brackets, okay? Okay, let's factor the polynomial 24x power 5 plus 3x squared y cubed. If the polynomial cannot be factored, write prime. If you take a look first, as you remember, we said in our techniques, always we try to find whether there are any GCF or not. So actually we have 24 and I have 3. I can recognize here a 3 as GCF. And I have also x power 5 and x power 2. So I can take x power 2 outside as well. So as GCF, we'll take 3x squared outside. So what's left inside now, in bracket, 8x cubed plus y cubed. Actually, this one can be written as sum of two cubes. I can write it 8x cubed and y cubed are both perfect cubes. Y cubed, it's clear that's perfect cube. 8x cubed means it's 2x times 2x times 2x. That's why I will have 8x cubed written as 2x all to the power of 3 plus y cubed. So using the rule a plus b, we say that 2x represent the a, y represent the b, then the factorizing will be a plus b means 2x plus y, here it is. The second bracket will be a squared means 2x squared minus ab, 2x times y, so it's 2xy plus b squared, so it's y squared. This is the sum of two cubes. Then we can simplify it to write it as 2x plus y multiplied by 4x squared minus 2xy plus y squared. This is simplified. We replace the GCF. So that would be our answer. 3x squared times 2x plus y times 4x squared minus 2xy plus y squared. Now, let's factor the polynomial 54x power 5 plus 128x squared y cubed. If the polynomial cannot be factored, write prime. You have to check it by yourself. Try if you can do it by yourself. Again, think we have 54 here, we have 128, x power 5 and x squared. So we have GCF here. You have to check what's the GCF, then use our method to factorize it. The answer here actually will be A, 2x squared times 3x plus 4y times 9x squared minus 12xy plus 16y squared. Let's factor this polynomial. 64 x power 9 plus 27 y power 5. If the polynomial cannot be factored, then we have to write prime. So if you take a look here, it's 64 x power 9 and 27 y power 5. Actually, there is no GCF can be taken here. I have y power 5, which is not a perfect cube. So actually, this polynomial is a prime polynomial, as I cannot write 27y power 5 as cube. So let's take a look again at our factoring techniques. For any number, the greatest common factor, we'll take it outside, then think about other techniques. If we have two terms, now we have the three of them. Difference of two squares, that's the normal one. Sum of two cubes or difference of two cubes. If it's none of them, then it is a prime, okay? So you have to check the GCF first, check difference of two squares. If it's not, check sum or difference of two cubes. If not, it's prime. If I have three terms, I'll think about perfect square trinomial, which is a squared plus 2ab plus b squared, and a squared minus 2ab plus b squared will be factored as a minus b squared. If it's not perfect square trinomial, we'll go to general formula to use guess and check actually in the general formula. If it's four or more, it's by grouping. So let's take an idea, or let's remember how we group. Let's factor this polynomial as x cubed plus 5x squared minus 2x minus 10. Now usually, or most of the time, that polynomial will be ready to be split into the first two together and the last two together. But you have to be careful when you have negative here. That means you cannot just add the bracket in here and khalas. No, give the negative to the 2x and put plus in between. Let's try to factor the first one. X cubed plus 5x squared. That's the original expression. Then we write it this way. x cubed plus 5x squared in one bracket, then give the negative to the 2x and put between the brackets plus always. Now we have x cubed plus 5x squared. Actually, I have a GCF here, which is x squared, and I have negative 2 as well. Don't forget to take the negative outside as repeated for both of the two terms. So I'll have x squared times x plus 5 minus. I took minus 2 outside, so what's left is x plus 5. Now, as you can recognize, I have inside the bracket x plus 5. So just take the GCF, x plus 5 outside, and you'll get x plus 5 times x squared minus 2. Now, x plus 5, I cannot factor more. Here, I have to stop. It's linear already. I cannot do further factorizing, so this is prime. Let's take a look at x squared minus 2. It's a binomial. The first one is perfect square. There is a minus here, so it's good, but I have a problem here. 2 is not a perfect square. That means this is not a difference of 2 squares, so it's prime as well. That means the answer finally is x plus 5 times x squared minus 2. Let's take another example. Take a look at a squared plus 3ay plus 2ay squared plus 6y cubed. If the polynomial cannot be factored, then write prime. Okay, so let's take a squared plus 3ay together, 2ay squared plus 6y cubed. That's my original expression. Put the brackets. Now I don't have a problem to directly put the brackets as there's plus at the third term, so I'm not scared to add the brackets directly. Now let's take out the GCF from each terms. A squared and 3ay. Yes, a is the GCF. 2ay squared plus 6y cubed. Correct. 2y squared will be the GCF. Now I have inside a plus 3y and a plus 3y. That means I can take them as GCF outside. It will be a plus 3y. So what's left here is a plus 2y squared. Again, a plus 3y, that's prime. A plus 2y squared, nothing can be done here. So this is my answer. Okay, what about this one? We can factor this polynomial again, and you're supposed to get d plus 2 times d squared plus 4. Now, if you got d squared plus 4, don't think to factorize. Actually, I have this is sum of two squares, which does not exist here. Okay, there is nothing called sum of two squares. So we just skip it this way, and that would be my final answer. Don't try to simplify more. Let's factor this one. It's r plus 2s times r plus 4s squared. Okay, now sometimes we need to combine cubes and squares. How it comes? Let's take a look at this polynomial. It's 1, 2, 3, 4, 5. Actually, it's 6 terms. We need to factorize. Usually, if it's more than 3 terms, we need to use grouping, as we said before. So if you look at the 3 terms here, x squared y cubed, 3x y cubed, 2 plus y cubed. Okay, I have y cubed repeated in the first 3 terms. Look at this one, x squared z cubed minus 3x z cubed plus 2z cubed. Actually, again, I have z cubed repeated. That's why the best way here, the only way here, is to take the grouping method. So we'll take the first 3 together and the last 3. We'll take from the first one y cubed outside. So what I have inside x squared minus 3x plus 2, and here z cubed times x squared minus 3x plus 2. As this term is repeated here, I will take it outside as GCF. And what's left will be y cubed plus z cubed. So actually, let's take a look at each one particularly. Y cubed plus z cubed, this is sum of 2 cubes. And I know there is a rule for sum of 2 cubes. X squared minus 3x plus 2. This is a quadratic equation, or quadratic polynomial, I mean, trinomial, that I can factor by guess and check. So y cubed, let's take it one by one. Y cubed plus y plus z cubed, it's like a cubed plus b cubed, where a equals y and b is z. So it will be a plus b times a squared plus ab plus b squared. That's right. So factorizing this one will give me y plus z times y squared minus yz plus z squared. These two are prime. Let's go to the third one here. x squared minus 3x plus 2. We said this is a trinomial factored by guess and check. How I'll do the guess and check? Remember, I'm trying to find two numbers. If I multiply, I'll get 2. If I add or subtract, I'll get 3. Yes, so it's 2 and 1. The last sign is positive. That means they will have, or they will carry the same sign. Which sign? The middle one. So it's negative, negative. That's why, again, I will rewrite this one here. And x squared minus 3x plus 2 will be factored as x minus 2 times x minus 1. Actually, this one will be the final factorization. And here is the answer. X minus 1, it's just I'm reordering it nicely. X minus 2 times x minus 1 times y plus z times y squared minus yz plus z squared. That would be my final answer. Okay, what about this one? Actually, this is a binomial. If I'm trying to think about GCF, there is no GCF at all in these two. 64x power 6 minus y power 6. Okay, now some of you could recognize a difference of two squares because 64 is 8 by 8. X power 6 can be written as x power 3 times x power 3. So it can be written as 8x all squared all to power 3 and y power 6 as well. Now, in this case, this polynomial could be considered the difference of two squares or the difference of two cubes. Whenever you have the choice to choose between squares or cubes, then the difference of two squares should always be done first to make it easier for factorizing. So let's consider this one as difference of two squares instead of difference of two cubes. So it will be written as 8x cubed times 8x cubed y cubed times y cubed. So 8x cubed plus y cubed times 8x cubed minus y cubed as difference of two squares. I consider these 8x cubed times 8x cubed. Y power 6 is y power 3 times y power 3. Okay, let's proceed. Let's take the first bracket. It's 8x cubed plus y cubed. Yes, it is sum of two cubes, where a equals 2x and b equals y. Same thing for here. 8x cubed, it's 2x to the power of 3 minus y cubed. So it will be written this way. 2x plus y times 4x squared minus 2xy plus y squared. The same exactly for the second part, but with different signs. Because if you can look here, it was plus, this is minus. Same terms exactly, but with different signs. So we go back and we write that. Remember that we have here 64x cubed, it's 8x cubed. I can rewrite it as a equals to 2x and b, sorry, b equals to y. Then I can factorize it as a cubed plus b cubed as a squared, sorry, a plus b, then a squared plus minus ab plus b squared this way. So I'll get 2x plus y times 4x squared minus 2xy plus y squared times 2x minus y times 4x squared plus 2xy plus y squared. Let's factorize this polynomial. Again, we have 6 terms in here. We'll try to, we have r cubed w squared, here is r cubed, and here is another r cubed. We have w squared y cubed, and y cubed repeated. So I can just divide them and split them as we did before. Then I'll have this one as my answer. Okay. Here's another example. We're using the same idea, split them into difference of two squares, then use the sum or difference of two cubes. Your answer will be A. Okay, let's take a little bit some word problem. Now, determine the dimensions of the cubes below if the length of the smaller cube is 1/2 the length of the larger cube, and the volume of the shaded figure is 23,625 cubic centimeters. So actually they said that there is a cube, cut from it a small cube, and they gave us the volume of the shaded part. They said that the small cube is half the length of the big cube. Of course, you could consider that some of you would think that, let's say that the side here from here to here is x instead of 2x. In this case, the side of the small cube will be half x. Why didn't we do that? It's not wrong, but actually you'll go deep now using fractions and cubes of fractions. And I know how much you love fractions. So instead of that, they said, make it easier to ourselves. Let's say that the big cube has a side of 2x and the small cube has a side of x instead of using fractions. That's why the big cube length side 2x and the small cube is x. So to find the volume of the shaded part, we'll do what? The volume of big cube minus the volume of the small cube. That actually give us the 23,625 cubic. I can find the volume of each of the shapes because actually I know volume of cube is side, or for any cuboid, length by width by height. And actually they are all same. That's why the volume of the big one will be 2x. 2x all cube minus the small is x cube equals to my number 23,625. Okay, that's what they have done. So actually we have 2x cube minus x cube equals 23,625. So simplify it, it will be 8x cube minus x cube means it's 7x cube. Then x cube will be equal to 3,375. Move it to the other side, you'll get x cube minus 3,375. Actually, this one is the perfect cube, 3,375. If you check using your calculator, you'll find its perfect cube where a equals 15, sorry, b equals 15 here. So in this case, a equals x, and b, using your calculator, you find it's equals to 15. So I'll have a minus b, which is x minus 15, times x squared, a squared is x squared, plus the opposite sign, a times b, 15 times x, 15x, plus 15 squared, 225 equal to 0. That means by zero product property, either x minus 15 equal to 0 or x squared plus 15x plus 225 equal to 0. So x minus 15 equal to 0. I'll get that x equals, of course, this is positive 15, not negative, this is by mistake. So x equals to 15, and the other one is x equals negative 7.5 plus minus 7.5i square root of 2. This is rejected. There is no such length. So this will be rejected. And I have this answer is accepted. This is accepted. That means the length of the small cube is 15, the length side 15, and the length of the large cube is 30. This is the small cube, and this one the length of the large cube. Okay, same way you can find the side length of this cube, which is 9 centimeter and 18 centimeter. It's exactly the same, just by changing the volume of the shaded to 5,103. You can do it by yourself. Okay, last thing we'll be talking about is the quadratic form. An expression that is quadratic form can be written as au squared plus bu plus c. Remember, or be careful that this u here is the same as this one. So whatever I'll have here, it will be the same. Okay, so not all polynomials can be written in quadratic form. Some of them can be written, okay, and some cannot. So let's take an example. For example, 2x power 6 minus x cubed plus 9. Now, if I take a look at this one, I have x power 6. I need to write it in the form of this one, which is x cubed. So I know that x squared, x power 6, can be written as x cubed to the power 2. To write it in quadratic form, it's called quadratic form because I have to see power 2 here outside. So the thing that will be inside here is x cubed, and it's the same as the second term. That means this is yes, it's possible. I can write it this way. So it will be 2x cubed. Take a look at x cubed here and x cubed there. It should be the same. I cannot have x cubed in one and x power 4 in the other. So in this case, I can write it as quadratic form. So that would be the answer, 2x cubed all raised to power 2 minus x cubed plus 9. Now, this one, can I write it in quadratic form? Actually, I need to write x power 4 as x power something all raised to power 2 to make it quadratic. Of course, 4, to make it 4, I need to be this one to be 2. If I can see this one, x power 2, while I have in the second term x power 3. So this one actually cannot be in the form of au squared plus bu. I have to see u in both terms, but I couldn't see that here. That's why this cannot be written in the quadratic form. Okay? Okay, so can we write this one in quadratic form? Let's take a look. We have 6, x power 10. Focus on x power 10 and x power 5. If I can rewrite x power 10 in the form of x power 5, that means I'm able to write it in quadratic form. Now, x power 10, that equals 2. X power something all raised to power 2. This one is 5. It's the same as the second term. That's why, yes, it can be written. It's possible. And the answer actually will be C. It will be 6x power 5 all power 2 minus 2x power 5. It's the same here. That's why I can write it in the quadratic form. What about this one? Power 8 and power 3. Again, x power 8, it will be written as x raised to some power, all supposed to be power 2, because I'm asking whether it's quadratic form. So what power 2 gives me 8? Actually, this is 4. X power 4 here, x power 3 in the second term. That means it's impossible. It's not possible. So this one cannot be written in quadratic form. Hopefully it's clear. Okay, I will use the same idea to solve quadratic equation of the form, or not quadratic equation, power 4 equation, x power 4 minus 29x squared plus 100 equal to 0. From my old experience, I know that when it's power 4, that means I have to get 4 roots or 4 zeros. Okay, so let's start solving this one. Now, the easiest way here is to convert it to quadratic form. So I can rewrite it as x power 2 minus 29x squared plus 100 equal to 0. Let's replace each x squared here with u. So it will be u squared minus 29u plus 100 equal to 0. I'm familiar with this shape. Why did I change it to power 2, x power 2 into u, to make it easier for me to factorize? Now this one is a trinomial, can be factored by guess and check. Two numbers, if you multiply, got 100. If you add or subtract, got 29. It's 4 and 25. Of course, last sign is positive. That means they will have same sign, which is negative, negative. So I'll get u equals 25 or u equals 4. But I'm not done yet. Remember, I have u is x squared, and I've got only 2 answers here. I have to change each u into x squared. So I'll get x squared equals 25 and x squared equals to 4. Now, x squared equals to 25. If you take the square root for both sides, you'll get plus minus 5, and square root of 4 will be plus minus 2. So here are the 4 terms. Because it's power 4, it should have 4 roots. So the solutions of the equations are negative 5, positive 5, 2, and negative 2, and they are all real solutions, no imaginary, no complex solutions. Let's check this one. X power 6 minus 35x cubed plus 216 equal to 0. Again, this one can be written as x to the power of 3 all to the power of 2 minus 35x cubed plus 216 equal to 0. Now this one can be written by replacing each x cubed by u squared minus 35 Again, remember that u is x cubed. So 35u plus 216, that equals to 0. Now continue factoring by guess and check. So the answer will be 2 and 3. Your answer will be 2 and 3. Thank you. That will be all. Thank you for watching.